Hi, and thanks for watching this video where I'll be discussing some of the reasons behind creating a link between Flownex and ANSYS Mechanical, and I'm also going to show you a quick example of how you would do that. Um, to start, our motivation is to create an interactive communication between a thermohydraulic system CFD and structural analysis software. In this way, detailed results of a 1D thermohydraulic system can be used in a 3D thermal and stress analysis. Co-simulation can then be achieved by feeding the results from this 3D analysis back into the system level simulation. The procedure we're going to follow, and I'll get it into the coding a little bit more later, is to create a library component using the Flownex extendability feature. We'll then use Flownex output to modify an ANSYS ds.dat file. We'll use this modified ds.dat file to run ANSYS in batch mode, and then write the results into a text file that is read by Flownex. Okay, so before I move on to setting up the link, I just want to explain our basic problem. What we're going to be doing is pulling a fluid temperature from this pipe in Flownex. We're then going to be feeding that into our thermal analysis in ANSYS Mechanical. So if I open up our 3D model, you can see this inner wall temperature is what we're bringing in from Flownex. We're calculating the heat loss due to convection on the outer wall, and we're feeding that heat loss value back into Flownex. This problem might be oversimplified, but again, its main purpose is just to illustrate the linking capabilities between these two softwares. Okay, so I mentioned in the beginning that the first step is to create a new Flownex library component. This is done by launching the Flownex extendability window. If I expand the library that I've already created, you can see the new components I've added, and you can also see the properties that I've created. So properties that are important to us here are the fluid temperature and the heat input, which we're going to be getting from ANSYS. So what is nice is I assign new properties to this component. I do that by right-clicking and selecting a value type. And then when I commit the changes to the library, Flownex will automatically create header files and source files in Visual Studios. So the structure and all my variables will already be declared in my project. So once I've done that, all I need to do is go and add the code I want it to execute. Another important part of this is adding a task. So a task is essentially how the simulation is going to be executed, that being either steady state or transient. If I open up Visual Studios to show you what's going on in the background, you can see that these variables have been automatically created by Flownex, and all I had to do was add a few functions to write these new variables into my ds.dat file. You can see that over here. I have another function that is executing ANSYS Mechanical in batch mode. I have a third function that is setting the results from a text file and assigning it to one of the Flownex properties I created in the beginning. So all that's really left for me to do is to hook up this new component to my Flownex network. I'll do that using data transfer links. Like I mentioned, from Flownex we're going to be using the fluid temperature, and from ANSYS we're going to be getting a heat input into the pipe. Once this is set up, I can go ahead and run my simulation. This command window will come up indicating that a system command has been executed to run ANSYS in batch mode. I can see that happening here. And what I'm going to do now is just focus on the results for a minute. I can see my average fluid temperature, my heat input calculated in ANSYS, and my fluid exit temperature. If I was to change my inlet temperature from, say, 100 degrees Celsius to 1000 degrees Celsius, we can see what effect that would have on my simulation. Immediately you can see our heat loss through our pipe is much greater than it was when our inlet temperature was just 100. I've plotted the results here as well. Zoom in to make it a little more clear. We can see that the spike in temperature has had an effect on our heat transfer. If you are interested in learning more about Flownex simulation environments, email, call, or visit the website and set up a discussion with our technical staff at PADT.